The hardest thing about learning virtualization, besides not getting enough sleep, is to learn about two-stage address translation. Therefore, in this video, I'll be talking about the topic, and my name is Tan Under, and let's get started. Firstly, let's take a look at what is not a two-stage address translation. Many people have the misconception that in two-stage MMU, we would have two sets of page table, one in the VS stage to convert guest virtual address to guest physical address, and another set of page table in the G stage to convert guest physical address to host physical address. This is not a correct diagram for two-stage MMU. Later on, we'll see the correct diagram. As a side note, two-stage address translation is not the same with two-level address translation. Here are some more clarifications regarding the two-stage address translation. VS-ATP and VS-stage page table is up to the modification by the guest. On the other hand, the host, which is the hypervisor, will handle the HGATP and G-stage page table, such that when given a guest physical address, it makes sure that the guest physical address is mapped to a corresponding host physical address by the proper G-stage page table setting for the GPA to HPA mapping. Here is the diagram to demonstrate the mechanism of the two-stage address translation. This GPA is the guest virtual address that is generated by the guest during its execution. And from this GPA, we can get the virtual page number, which we can combine with the physical page number of the VS-stage root page table as specified in the VS-ATP to get the guest physical address of the entry inside the VS-stage root page table. And when we plug in the GPA into the G-stage page table, we will get the physical page number of the VS-stage next level page table. And again, we combine it with the virtual page number to get the guest physical address of the entry inside the VS-stage next level page table. Again, we use the guest physical address, plug it into the G-stage page table, and we get the physical page number of VS-stage leaf page table. And by combining this with the virtual page number, we get the guest physical address of the entry in the VS-stage leaf page table. And again, we use this GPA, plug this GPA inside the G-stage page table. What we get is the physical page number of the guest virtual address. Finally, combining with the offset as specified in the guest virtual address, we get the guest physical address corresponding to the guest virtual address. And using this GPA, again, we plug this GPA into the G-stage page table, and we will get the final host physical address. So this is how the guest virtual address is translated into the host physical address. When the guest read from the GPA, what it read is actually the content of the memory at this location. And when the guest write to the GPA, it actually writes into this memory location. I mean, the blue square here is an actual physical frame inside the physical memory. And HPA is an entry inside this frame. Let's take a look at the scenario where we have VS-stage page fault. A VS-stage page fault can happen, for example, when we reach here and the page table entry here says that the next level page table of the VS-stage is not valid, then there will be page fault exception. This page fault exception can be delegated to the guest using the HEDE-LEG register. Another scenario is where we have G-stage patch fault. A G-stage patch fault can happen, for example, let's say when we reach here and we don't have a valid mapping to this patch right here. So this will cause the G-stage patch fault, also known as the guest patch fault in the spec. And this guest patch fault will cause the guest to exit into the host so that the host can complete the G-stage mapping. That's all for what I want to share in this video. For the references, you may refer to a more extensive diagram in the issue inside the GitHub here. And you can also take a look at how the G-stage mapping is done in the sample code inside the Linux kernel or in the Hypervisor tool, which is a type 1 hypervisor. Let me end this video by presenting a quote from a famous philosopher. We suffer more often in virtualization than in reality. Therefore, we must be patient while learning virtualization. Thanks for watching.